Okay, yeah, let's get started. Okay. Okay, so not much happened last week. I prepared for the new release. So a couple of protocol features are going to be stabilized in the next release, and yeah, also fix some Python tests. I think there are a couple of tests that some of them fail because some of them are kind of flaky because the assumptions because we rely on some kind of very tenuous assumptions that could easily break. Yeah, Alex, did you have the chance to look into the light client test?
Yeah, it's the PR is out.
Oh, okay, great. Okay, I think not much else happened in terms of updates. We can discuss more about sharding. More specifically, we can talk about something that has more immediate impact, which is how we want to split the state. I think there have been different opinions on that, and it's actually one of our OKRs for this quarter to figure out how we want to split the state. I think a proposal is to for now split by top level accounts. And once we transition into 8 shards, essentially what will happen is that all the accounts with .near top level accounts and all the top level accounts longer than 32 characters will go into 1 shard, and then other top level accounts with other top level accounts will go into other shards. This is the idea is that we do this for now. This should not prevent us from doing something different in the future. And also it's easier to implement once we get to it. And yeah, basically that's the proposal. I want to check whether there are different opinions here, and yeah.
Well, I think that any idea to split them based on the state based on top level account or something like that assumes that we want some sort of synchronous communication between account with the same top level account. And well, I am for all asynchronous, in which case we can split the state like in arbitrary way, as long as a single account is completely on a single shard, but different account can be possible on different shards, even no matter how close they are. So even if they have the same top level account, or even if they have the same second level account, it shouldn't matter, because we want to have the same paradigm for communication between any different accounts. Don't we? Well, there is an idea that we don't want to have any sort of collocation or closeness between different accounts that enables some sort of different way to communicate between them, such as synchronous calls or anything else.
So what is the disadvantage? So let's say it's not top level for now. Let's say it's second level accounts that are collocated. What's the disadvantage of doing that? Even if we choose not to disable.
Disadvantage that if some or some account has high volume of transactions, we want to be able to isolate it so that, for example, probably VM is going to have a high volume, so we want to make it possible for it to be separate from other accounts. And similar, it is possible when any other accounts gets high volume, and ideally we want some sort of automatic resharding that can, if an account gets a lot of volume, which will put it in a separate shard.
Well, so I think there are two things, right? So one is that I don't think the scheme that I just proposed prevent us from in the future reshard based on volume and usage. And second thing is that I don't think that resharding can be implemented anytime soon. So even if we decide to go
Probably
with
automatic resharding is not going. So yes, I agree that we can currently go with some scheme like sharding based on top level account, but we should not do anything that would prevent us in the future from splitting accounts differently. So as I said, we probably don't want to have some sort of synchronous calls or whatever, which will make it impossible to later split those accounts into separate shards.
okay, what do other people think?
I mean, if we either commit to making it overthink, or we should, in our sharding decisions, keep accounts that we theoretically want to collocate on the same shard, I guess. Or actually, we can be shard in the future in such a way that accounts that were not collocated would collocate. But generally, I agree that the better decision would be to have async everything. Maybe, yeah, something like that.
Sorry, the last part, I didn't hear it clearly.
I mean, I agree with Evgeny that that if we want if you want our sharding to lead to fast network, that we should do everything async to avoid accounts, to avoid contracts to rely on things on the ground being collocated and in sync.
Okay, I see. Yeah, Piotr, do you want to say something? I saw you unmuted. Or if you're trying to say something, we cannot hear you. Okay, maybe there's some problem with microphone. Okay, so it seems like we kind of at least agree that in the short term, we can shard based on top level accounts. So basically, given the existing top level account, I think in the beginning there will be two shards, one with .near, one with Aurora. And I don't think we plan to deploy any other top level account anytime soon. So what use case we would lose if we were not to support synchronous calls? It's less about use case, it's more about the developer experience. So of course there are some use case that would not be supported if we do not allow synchronous calls. But I think it's more about if we don't support about asynchronous calls, the problem is that it's much harder for developers to write certain things. Like I think we talked about last time. Like if you want to swap a token A for token B, and then after you got token B, you use token B to do something else. The problem is that what happens if when you use token B to do something else, and that something else failed on the other contract, now you cannot actually roll back it's actually just more difficult to roll back the state that you touched in between. So that's kind of the issue. Is that clear? Okay. Okay. Is there let's see? Yeah, Alex, do you want to discuss something else?
Nothing in particular.
Okay. Yeah, I'm not sure. So Piotr said, yeah, he's wondering whether there's a way to build a mechanism around it to still use async and make it easy as well. Yeah, I don't know.
I think it certainly can be made easier than it is currently, because currently it's not very well designed, but it will be more difficult than in the synchronous case, because it's not synchronous. So it will be, I think, in the end, it will be something like async programming in regular languages, like in JavaScript. So you can just write await somewhere, and you know that when you evaluate that there's some other pieces of code may run in between. So you need to be aware of the possibilities of race conditions if those code can access the same state. But it shouldn't be as inconvenient and as it is currently.
So I guess what inconvenience are you referring to right now?
Currently, if you want to write the code which involves which involves cross-contract calls and returns, it's not convenient. You need to write your own callback functions. You need to write various checks like that, everything. You need to, it's even less convenient if you want to handle failed calls and the problems that we mentioned, that you need to assume that some amount is enough for your callback, also complicates things.
It seems that
so we want something like async await. So you do a cross-contract call, you just await it, and your execution continues in the current function.
That seems more like a change on the SDK level, if I understand you.
Yes, sure. So there are many changes on the SDK level, but that's also like SDK is even more important to developer experience, because that's what they're interacting with. but some changes on the runtime level are also needed. And one of them is to get rid of this gas problem that the developers need to know how much gas is enough, because this can't be easily solved in the SDK.
Okay. Yeah, anything else that people want to discuss here? Okay, looks like no. Okay, so yeah, we can